A key component of HDFS is the file system namespace itself. In other words, the hierarchy of where data is stored. HDFS exposes a file system namespace and allows user data to be stored in files, much like we're used to in traditional operating systems. The HDFS does use a hierarchical file system that does include directories and files within those directories. The name node manages the file system namespace, allowing clients to work with files and directories. A file system supports operations like create, remove, move, and rename. The name node, apart from maintaining the file system namespace, records any change to metadata information. Name node operation. The name node maintains two persistent files, a transaction log called an edit log and a namespace image called an FS image. The edit log records every change that occurs in the file system metadata, such as creating a new file. The name node's local file system stores the edit log. The entire file system namespace, including mapping of blocks, files, and file system properties, is stored in FS image. This is also stored in the name node's local file system. When new data nodes join a cluster, metadata loads the blocks that reside on a specific data node into its memory at startup. Metadata then periodically loads the data at user-defined or default intervals. When the name node starts up, it retrieves the edit log and FS image from its local file system. It then updates the FS image with edit log information and stores a copy of the FS image on the file system as a checkpoint. The metadata size is limited to the RAM available on the name node. A large number of small files would require more metadata than a small number of large files. Hence, the in-memory metadata management issue explains why HDFS favors a small number of large files. If a name node runs out of RAM, it will crash, and the applications will not be able to use HDFS until the name node is operational again.